So today we're going to be taking a look at count-controlled loops, or better known as for loops. So why loops? It's a great question. And in order to answer this, I think that we should step through an example together and the answer will kind of just be shown for itself. So let's consider this scenario. Print the statement eecs 10 times. My first initial thought is let's just use print statements. So we could see out eecs, see out eecs, see out eecs 10 times, and this would give us exactly what we want. But now what if I asked you to do that 100 times? Maybe even 1,000 times. That would get quite annoying quickly. And there's a much easier way to do that. And that's by using loops. In just 3 lines of code, we could do exactly what we did on the left in a much more efficient way. In summary, loops allow us to avoid code duplication, which as programmers for us, that's awesome. We're always looking to get rid of that. And then another very useful thing about loops is that it allows us to repeat code for a certain amount of times, which is very important when dealing with like containers and that kind of stuff. So now let's take a look at the very basic functionality of a for loop. So first, the keyword for indicates that we will be using a count controlled loop. And inside the braces here, it essentially just means however many times we want to iterate through this loop. And then inside the curly braces, it's just the code we want to repeat. So now digging into like the more nitty-gritty part of these for loops, there's a few steps that I think that we should go over first. Step 1 is the initializer. The initializer in this case is int I equals 0. And this is essentially just a variable that keeps track of how many times we've iterated through the loop. Step 2 is to check the condition. And in this case, the condition is I is less than 10. So as long as this condition is true, we will move on to step 3. However, if it's false, then we will step out of this loop and continue on with our code. Step 3 is running the code. So inside the curly braces, this is the code that we want to repeat. And as long as the condition is met, we will see out this statement. Step 4 is to update our variable I, which is our initializer that we made, and then go back to step 2. So in this case, it looks like we're just incrementing it by 1 each time. So in order to get a better look at these steps that we laid out on the previous slide, I say that we take a look at an example together and step through it. So they ask us, how many times does this loop iterate? Okay, so let's take a look at what they're giving us in our for loop and kind of lay out the steps. So step 1 is the initializer step. And in this case, our initializer is int I equals 0. So I will be set to 0 at the start. Our condition is I is not equal to 3. So if I is equal to 3, then we will step out of this for loop. But if it comes out to be true, then we will move on to step 3, which is going to be running the code. And in this case, we're going to be couting eecs. Step 4 is updating the variable, which in this case, it appears that we're just incrementing it by 2. And then for step 4, after that, we're going to remember we have to return to step 2, which is checking the condition once again. So let's take a look. So I equals 0. 0 is not equal to 3, so we're going to count eecs. Okay, now we'll update it. I is now equal to 2. And 2 does not equal 3, so we're going to count one more time. And now we're going to update the variable again. I equals 4. 4 does not equal 3, and we're going to count again. Update it one more time. I equals 6. 6 does not equal 3, so we would count again, but there's a problem. See, now, if we keep going and you keep looking at this, we're just going to keep getting a bigger and bigger number, and our condition is never going to be met. This is what we call an infinite loop. This loop would generate an infinite loop because it would iterate infinite amount of times. That's because our condition would never be met. This would eventually crash your program, and your computer would get really, really, really slow. So a few key takeaways from today is loops are very important for removing code duplication. Loops allow you to iterate through a piece of code a certain amount of times, and if anything else, please, please, please make sure that your condition is going to be met to avoid the infinite loop. So I hope you guys learned a little something today, and I hope you have a great rest of your day.